Determine all critical numbers for the function f of x equals x times the square root of 3 minus 2x. Critical numbers are the x values that make the numerator and the denominator of the derivative equal to 0 and are in the domain of the function. The first thing to do is find the domain. F of x is x times the square root of 3 minus 2x. The square root is an even root. It can be rewritten as a 1/2 power. The denominator there is the root, so we have an even root here. The domain of an even root isn't necessarily all reals. What's inside of an even root has to stay greater than or equal to 0. So we have 3 minus 2x has to stay greater than or equal to 0. We can solve for x here by subtracting 3 from both sides. So minus 2x is greater than or equal to minus 3. And now divide both sides by a negative 2. If you divide or multiply by a negative, the inequality does flip. The negatives will cancel because there's a negative on each side, and it will become 3/2, but we have to flip the inequality since we divided by a negative. So we have the condition x is going to have to be less than or equal to 3 over 2. Now outside of the square root there's an x. That's a polynomial, and a polynomial has a domain of all reals. So it's only the condition coming from the square root that matters here, and we have to have x be less than or equal to 3/2. The domain is all numbers less than or equal to 3/2. It will therefore start at negative infinity, go up to 3/2. It does include it, so square bracket on the 3/2. The next thing to do is find the derivative, f prime of x. F of x is a product of x times 3 minus 2x quantity to the 1/2. So we use the product rule. Derivative of the first derivative of x is a 1 times the second left alone. 3 minus 2x to the 1/2 power. Plus the first left alone, x, times the derivative of the second. It's a power rule. Bring the power 1/2 down, leave the inside alone. 3 minus 2x. Subtract 1 from the power. I will call that 2/2, and then multiply by the derivative of the inside to complete the chain rule. Derivative of 3 minus 2x will be a minus 2. So f prime of x equals, the first term is 1 times 3 minus 2x to the 1/2 power. 1 times anything is itself. In the second term, we can collect the constants together. There's a 1/2, and there's a minus 2. 1/2 times 2 is 2/2, or 1. With the negative is negative 1. So we can put that out front. It'll be a minus. There's an x out front already. And then there's a 3 minus 2x to the 1 minus 2, negative 1/2 power. Since we have a negative power, we will move that to the denominator to make it a positive power. So the x will stay in the numerator, and the 3 minus 2x has moved to the denominator to become a positive 1/2 power. At that point, we have a term that is a fraction, and if the derivative ever has one or more terms that are fractions, we have to get a common denominator between all terms and combine it into a single fraction to find critical numbers. So we need to take the first expression and give it a common denominator by multiplying it by 3 minus 2x to the 1/2 over itself, a form of 1. So we're not changing the value just a look, but this will put it over a common denominator with the second term, which is negative x over the 3 minus 2x to the 1/2. So f prime of x equals, the first term is going to have a numerator of these two multiplied with each other. We will add the exponents, 1/2 plus 1/2, which is 2 halves or 1, so it'll be 3 minus 2x to the 1, which is just 3 minus 2x, combined with the other fraction numerator, which is a minus x, because they are now over a common denominator of 3 minus 2x to the 1/2 power. We can combine like terms together in the numerator, which will give a minus 2x minus 1 more x is a minus 3x, all over. 1/2 power can be rewritten as square root of the 3 minus 2x. And one more thing we can do, there's actually a common factor of 3 in the numerator, so we can factor 3 out. To get it to a simplified form of the derivative. Now that we've put the derivative into a single fraction, we can set the numerator equal to 0, and we can set the denominator equal to 0, and solve for all x's. Starting with the numerator, 3 times 1 minus x equals 0. We can divide both sides by 3, so 1 minus x equals 0. Subtract 1 from both sides, so negative x equals negative 1. And multiply both sides by a negative 1, so x equals a positive 1. Now working with the denominator, the square root of 3 minus 2x equals 0. We can start by squaring both sides. Square root squared cancel each other out, so 3 minus 2x equals to 0 squared is a 0. We can subtract 3 from both sides. Now we can divide by a negative 2. The negatives will cancel. And I'll give us 3 halves. Now we'll make sure that these are in the domain. The domain here is negative infinity up to and including positive 3 halves. X equals 1 is less than 3 halves, so it is in that domain, and we keep that. X equals 3 halves is in the domain by being the right endpoint of the domain, but it is in there, so we will also keep that. And there are 2 critical numbers for the function, x equals 1 and x equals 3 halves.